The USDA My Plate guidelines suggest that individuals devote at least a quarter of their plate to vegetables at every meal. The American Cancer Society and the American Heart Association both endorse the use of vegetables in the human diet for a variety of reasons, mainly to reduce the incidence of cancer and heart disease. The branch of horticulture dealing with the production, storage, processing, and marketing of vegetables is called Olericulture. Vegetables can be produced commercially or in the home garden. Commercial vegetable production is divided into two distinct areas, fresh market and processing. The total of vegetable crops in the United States is estimated to be 14.7 billion per year and is on the rise. The top two vegetable producing states are California and Florida. Although most of the vegetables are produced by traditional methods, a growing number of people prefer vegetables grown organically, which means without chemicals or inorganic fertilizers. I'm Dr. DeBusk, and in this video, I'll discuss how to select, plant, grow, and store vegetables. Vegetable crops can be classified in a variety of ways. The two most commonly used methods are edible parts and scientific classification. Classification of vegetable crops by edible parts can be broken down into 9 major categories, such as cole crops, which include cabbage and cauliflower, cucurbits, including melon, squash, and cucumber, and solanaceous crops, including tomatoes, peppers, and eggplants. To produce a high-quality vegetable crop with high yields, the grower must select the best site, facilities, and the proper cultivar. After these selections are made, the seedbed must be prepared. The grower then establishes vegetable crops from seed or transplants, followed by proper care and maintenance. To select the proper site, environmental and economical factors should be considered. Many hybrid cultivars are superior to standard cultivars. A hybrid is an improved plant developed by crossing parents of different genotypes for a beneficial trait. Cultivars are selected based on climatic requirements, temperature, water and light, life cycle, cultural requirements, usage, and quality. All plants have an optimum temperature range for peak efficiency, which generally differentiates between warm and cool season crops. The frost-free period is the average number of days from the last spring frost to the first frost in the fall. This is the main selection criterion when selecting a cultivar because without the proper temperature, there is no growth and the grower has limited means of affecting temperature under field conditions. Vegetable crops demand a consistent supply of water, even as minor water stress will lead to reductions in crop yields. Excessive water can promote disease and drown the plant by preventing oxygen uptake by the root system, so it is important to select a cultivar that is adaptable to the location. Vegetable crops must have the proper light intensity, quality, and duration to maximize growth and development. Most vegetable crops are grown as annuals, although many can survive more than one season. Examples of annuals, biennials, and perennials are corn, carrot, and asparagus, respectively. Understanding how long it will take for a specific cultivar to produce a vegetable crop that is saleable helps the grower prepare to market the crop. Knowing what the vegetable crop is to be used for, processing or fresh market, helps the grower select a cultivar for maximal performance. In addition, the yield, disease resistance, and horticultural characteristics such as color, size, flavor, shape, and appearance are all very important factors to consider when selecting vegetable cultivars. Next, seedbed preparation is essential for the production of high-quality vegetables. A soil test should reveal pH and nutrient requirements. The grower must also control weeds and other pests at the planting site prior to planting. Add organic matter and/or sand as necessary to improve soil structure, till the soil, and install irrigation systems as needed. Tillage is generally one of the earliest operations performed in crop establishment. Tillage improves the soil environment by increasing aeration, increasing moisture infiltration, controlling weeds, and incorporating crop residue. The initial tillage buries crop residue and loosens the soil to enhance root growth, which is typically followed by disking to smooth the seedbed and incorporating fertilizers and weed control chemicals. Conservation tillage, also called minimal tillage, involves tillage practices that leave 30% or more crop residues on the top of the soil to prevent soil erosion. The most common form of conservation tillage used in vegetable production is strip tillage, which is the process of leaving strips of vegetation between tilled areas to prevent soil erosion. Tillage continues after a crop has been planted, but it is then called cultivation. Cultivation is primarily used to control weeds, to incorporate fertilizer, to break soil crusts, and to improve the infiltration of water. Several methods of irrigation are used to supply moisture to the soil. Subsurface irrigation, commonly used in association with a shallow water table, surface irrigation such as furrow or drip irrigation, and overhead irrigation such as sprinklers. After the seedbed is prepared properly, the final step is crop establishment, which can be done by direct or indirect seeding. The particular spacing depends on the crop and its intended use. Manual seeding is done on small-scale plantings because it is quick, easy, and inexpensive. However, it is not cost-effective to use this method on large scale. Precision seeders are commonly used for large-scale commercial plantings. Vegetable seeds come in a variety of shapes and sizes, which makes them difficult to use with precision seeders. To overcome this problem, vegetable seeds are often coated to make them a more uniform size, thereby facilitating the use of precision seeders for a wide range of vegetable crops. Fluid drilling is a method that uses seeds that have been treated, pre-germinated, suspended in gel, and placed in precision seeders that deposit a designated number of seeds per hole in the soil by an automated process. Fluid drilling is usually used in conjunction with plastic culture. Indirect seeding is the transfer of seedlings, transplants, from a seedbed or container to the field. The main advantages are to assure a good stand of crop plants and extend the length of the growing season, especially in cooler climates. The main disadvantages are that transplants cost more and are subject to transplanting shock, which is a 1 to 2 week period following planting in which no growth occurs because of the shock. When the vegetable crop has been established properly in the field, it must be maintained and cared for properly by maintaining pH levels and nutrients, watering, controlling pests, staking, and training as necessary. Vegetable crops require additional fertilization as they develop throughout the growing season. Over-fertilization can be as equally damaging as under-fertilization. Foliar analysis of nutrients should be done throughout the growing season to determine the needed nutrients, and then fertilizers should be applied as needed. Fertilizers applied by side dressing should be a couple of inches from the plant, and dry fertilizer should never be applied to foliage of plants because it will cause burning. Watering should be based on the crop's demand because more water is typically required than is available from the environment. Irrigation should be done with 3/4 of an inch 2 times a week. This way is better than daily applications, which do not promote a deep root system. Watering in the early afternoon cools the plants during the hotter part of the day, prevents interference with pollination, and enables the foliage to dry prior to nightfall to prevent the spread of diseases. Common pests in vegetable crops are insects, weeds, diseases, and animals. As stressed throughout these videos, the growers should first try to prevent the pest from attacking the crop. If this is not possible, the pest should be identified properly. After the pest is identified, an IPM strategy, including cultural, biological, chemical, genetic, and mechanical methods, should be used to control pests. Some vegetables must be staked or trained in some manner. For example, pole beans and tomatoes. If staking is not done, the fruits will lie on the ground and lead to problems with rot. Staking also maximizes available space. Modifying temperatures for the successful growth of crops can be achieved in several ways. The first method is to grow plants in a greenhouse. However, this is not a cost-effective method for many vegetable crops. Other methods used for frost protection are row covers, sprinkler irrigation, and fogging, whereas in extreme cases, heaters, smudge pots, and fans are used. Neither of these steps are effective with deep frosts. Plastic culture or plastic mulch method to modify soil temperatures is typically used in conjunction with drip irrigation. Plastic mulch has become very popular because of the many associated advantages such as reduced weeds and increased moisture control. Plastics now come in a variety of colors to suit specific needs in addition to temperature control. Vegetable crops are also susceptible to heat injury. In warm season crops, temperatures between 80 and 95 degrees Fahrenheit cause injury, whereas in cool season crops, damage occurs between 75 and 85 degrees Fahrenheit. The type of injury observed in both warm season and cool season crops is premature flowering and reduced crop yields. Vegetable crops can be protected against heat injury in the same way they are protected from low temperatures. Adequate air movement is required for good plant growth because it decreases humidity, reduces the incidence of disease, helps cool the plant, makes the plant develop a thicker cuticle to protect itself against pests, facilitates pollination, replenishes beneficial gases such as carbon dioxide, and provides a variety of other benefits. However, excessive air movement has a negative effect on photosynthesis and crop yields, can cause physical damage, and spreads disease, weed seeds, pollutants, and airborne pathogens. Wind protection can be achieved by planting trees, hedgerows, or tall grasses as windbreaks. Did you know that most potatoes, onions, shallots, and garlic have a growth retardant sprayed on them to keep them from sprouting so fast? Plant growth regulators, PGRs, are important in the production of vegetable crops, starting with seed germination and continuing through storage of the produce. PGRs modify the crop's growth and development or control the fruit coloration and abscission. These chemicals are highly regulated because they are used on plants or their products, which will be consumed. It is important to understand the factors that control their effectiveness so the maximum benefit can be achieved by using them. Growers should know when crops are at peak color, flavor, and overall quality. Vegetables are harvested at different stages of maturity for different uses and markets. For example, in the fresh market, tomatoes to be used in distant markets are picked in the green stage, whereas tomatoes that are sold that day are typically picked when they are red ripe. Vegetables to be used for processing are often picked based on acid, sugar, and color levels, which can be measured using instruments. The time it takes for a vegetable crop to mature can be measured in two ways. The first way is to count the number of days from planting to maturity. However, the rate of maturity for each crop depends on temperature and rainfall, so this is not the most accurate way to determine the maturation time. The second method measures the time to maturity more accurately by using degree days. Add the daily high and low temperature together, divide by 2, and then subtract the base temperature for this specific crop, which is the lowest temperature at which growth can occur. Many vegetable crops are now picked mechanically, such as tomatoes and peppers. However, most large vegetables, such as watermelons, are still picked by hand. After vegetables are harvested, the area should be cleaned and any stalks or vines should be chopped and put into a compost pile or plowed back into the soil. Vegetable crops are still living when attached from the plant. The first step following removal from the plant is to remove field heat rapidly and to place the vegetable under the appropriate storage conditions. Organic production methods do not use or only use reduced amounts of chemical pesticides or inorganic fertilizers. Organic production is more costly and generally results in lower yields and quality of vegetables because of disease and insect problems. However, in recent years, considerable strides have been made to increase yields and quality. Instead of inorganic fertilizers, organic production uses cover crops, manures, compost, and sludge. Pest control used for organic production is an IPM program without the use of chemicals. Sanitation, crop rotation, biological control, crop resistance, and natural chemical compounds are generally important measures used for organic production. The benefit of organic vegetable production is that no chemical inputs are leached or run off into the water supply and soil. The main disadvantage is the higher cost to the consumer. Sustainable horticulture uses integrated pest management (IPM) together with sound management practices to reduce inputs such as tillage, chemicals, inorganic fertilizer, and water. Home vegetable gardens are very popular because large quantities of vegetables can be produced from a very small portion of land if the garden is planned properly and the grower is knowledgeable. Proper planning includes selecting the proper location, choosing what to plant, and deciding how the plants will be arranged. The garden location should be near the home, but in the open where it gets full sun, near a water source, have fertile soil, and have good aeration, drainage, and nutrient and water holding capacity. In general, a sandy loam soil works best for most vegetable crops. After the garden is planned, the soil must be prepared for high-quality, viable seed or transplants to be planted at the proper depth and distance apart. The next steps are controlling pests, watering, staking, training, and putting in windbreaks where necessary. To harvest at the proper time, the grower must know when the vegetables are mature and how to store or process them to maximize his or her time investment. At the end of the season, the area should be cleaned and all plant material chopped and then plowed into the soil or used for compost. In conclusion, olericulture is important to the homeowner and the commercial producer. Many important factors must be considered when preparing the seedbed, establishing vegetable crops by seed and transplants, and maintaining vegetable crops.